This video is for Module 1, Part 2. Okay, let's go ahead and get started. Again, you're going to want to make sure that you are logged into your statsclass.org account before completing the notes. The notes have some open-ended questions that need to be submitted, so make sure that you have a Submit button at the top of your notes as shown as here. Module 1, Part 2 is going to discuss a simulation model that can be used to mimic deaf people. This model needs two important pieces of information, and that is the number of completed trials, which here is 20, and also the likelihood or chance of a correct response, which is going to be 1 out of 2. This simulation could be used by simply flipping a fair coin. A fair coin is going to have a 1/2 chance of landing on heads and a 1/2 chance of landing on tails. We could let the heads indicate a correct response and the tails to indicate an incorrect response. We would simply need to flip that coin a total of 20 times and just record how many heads I obtained. That would be equivalent to identifying how many correct guesses a deaf person would obtain out of 20 trials. An alternative would be to use the hearing simulation app. The first thing that I'd like you to do here is to go ahead and conduct 20 trials using this hearing simulation app. The goal here is to mimic the outcomes of a deaf person. Therefore, when using the app, make sure your computer speaker is muted. The link for the hearing simulation app is provided here in the notes. You can use the following table in the notes to indicate your guess and whether or not whether or not your guess was correct. So let's go ahead and go to the hearing simulation app. Select Begin Simulation. It'll take a moment to load here. The red light is being shown. And then the blue light is being shown. And for that simulation, or that trial, the sound was being played with the blue light. Now, in order to mimic the outcomes of a deaf person, we're going to need to put our computer on mute. And then we'll go ahead and rerun this simulation with your computer speaker muted. That means you're going to have to simply guess at what light was on when the sound was being played. So I'd like you to do that a total of 20 times and then simply record how many outcomes you got correct. All right, let's go ahead and next consider the following outcomes from the hearing simulation app from 24 other students in the class. So again, what is being plotted on the x-axis here is the number of correct. The smallest possible for number correct would be 0. Actually, for many of the examples here in the first part of this course, the smallest number on this number line is going to be 0. That's the smallest number of correct that somebody could get. The largest number possible on this number line is going to simply be the number of trials. So maybe a deaf person could get really, really lucky and get 20 out of 20 trials correct. So their dot would be way up here at 20. You can see that these dots are kind of centered around 10. 10 again is my expected outcome for this simulation model. Some people are going to be slightly off of 10. So it looks like I had 2 different people, 2 different deaf people, or maybe I should say 2 different people that are mimicking a deaf person had 9 out of 20 correct. If we slide over here to 12, looks like 2 individuals had 12 out of 20 correct. Okay, let's go ahead and answer the following questions here. So, question 1A, how many correct did you get out of your 24 trials? So when I did this, I got a total of 9 correct out of 20. How about 1B? Is your outcome similar to the other 24 students? So if my outcome was 9, it looks like it's quite similar to the other 24 students. It's not on the expected value of 10, but it's pretty close to the expected value. So I got a total of 9 correct out of 20. Is your outcome similar to the others? Yes. My outcome is very similar to the other students. My outcome was 1 away from the expected number. How about the second question here? How many correct would you expect me to get in the 20 trials? So your best guess for the number of correct for a deaf person is going to be the expected outcome. So for question 2A, the expected outcome is 10. Again, in order to determine this value, what you need to do is just simply take the number of trials times the chance or the probability of getting a correct guess, which is 1/2 here. So 20 times 1/2 is 10. That's how that value is computed. How about question 2B? What is the most number of correct that I could have gotten? Well, the most is going to be 20, which again is just the number of trials. So I could have gotten them all right. And the least here, number of correct, as we stated a moment ago, is 0. This is the smallest number possible. So this is none correct, right? And the number of trials, that's going to be they're all correct. So if a hearing person took this test, I would expect them to be, again, on the high end of that number line. Right? So if a person could indeed hear, they're going to be up here on the high end. If they're in the middle, that means they cannot hear. That's deaf people. And if they're down here on the other end, again, that's going to indicate that they were lying. So let's consider question 3. Which of the following statements is correct? Statement A is these dots are meant to mimic the outcomes of a deaf person, or statement B, these dots are meant to, statement B, these dots are meant to mimic the outcomes of a person who is thought to be lying about their ability to hear. Okay, I think I've stated this several times here, but statement A is correct. These outcomes are meant to mimic a deaf person. Okay, we obtain them, okay, with our speakers muted. Okay, so indeed these are meant to mimic a deaf person. Now this is a little confusing because we are trying to determine whether or not somebody is lying about their ability to hear. But that's not the dots that we obtained. The dots that we put onto this graph are meant to mimic a deaf person. Okay, we're trying to make a decision about whether or not an individual can hear, but our first step in our simulation model is to mimic deaf people. If I have a good idea of what the outcomes would be for a deaf person, then I can evaluate whether or not somebody is lying about their ability to hear. How about question 4? Consider the simulation results above. What can we conclude about an individual that gets 7 correct? Let's go back up to the graph a minute. If an individual gets 7 correct, so they're going to be right here, then they're kind of within the realm of the deaf people. So even though 7 is slightly below what I would expect for a deaf person, it's still within the realm of what deaf people would produce. How about a value of 0 or a value of 1? Well, as I indicated earlier, those are going to be values where I'd expect the individual to be lying about their ability to hear. How about values 2, 3, and 4? Okay, so these values right in here, 2, 3, and 4. Those are also going to indicate lying values, or maybe kind of a gray area between the deaf people and the lying individual that is lying. So one thing that's going to happen is that an individual who is trying to beat the system is not going to get all of them incorrect, because then they would probably believe that, hey, I might get caught if I get them all incorrect. So they're probably going to try to compensate a little bit and get some of them correct. Okay, just so they don't believe that you're trying to beat the system. So these values 1, 2, 3, and maybe even 4 most likely also indicate that an individual is lying, because it's out of the realm of the deaf people. So it looks like for these 24 outcomes here, I don't have a lot of outcomes yet, but it looks like for the 24 outcomes, kind of the lowest value that I would expect to see is a 5 for the number correct for a deaf person. Let's go ahead and answer each of those. So question 4A is going to be 7 correct. Well, 7 correct is within the realm of deaf people. Okay, so the person, or this individual, or this subject may be deaf. Question 4B, how about 0 or 1 correct? And we said that that means this person is likely lying about their ability to hear. And then question 4C, a 2 or a 3 or a 4, 2, a 3, or 4 would also indicate that the person is lying. Okay, because these outcomes were not obtained when simulating outcomes for a deaf person. So a little bit more about evaluating evidence here. So how do we do this? Well, actually in the real study, the subject was asked to complete not 20 trials, but 100 trials. So here I'm going to let a computer simulate the possible outcomes for a deaf person. So again, my number line now is going to go from 0 all the way up to 100. Again, the maximum value on this number line is the number of trials. The computer is going to keep track of the number of correct guesses out of the 100 trials. Now, when a computer is used, it's easy to obtain many, many repeated trials or many, many simulated outcomes. Here, looks like I got 150 repeated outcomes. Okay, so 150 repeated simulations were used, okay, as a reference for outcomes for a deaf person. Now, the subject in the actual study got a total of 36 correct out of the 100 trials. 36 is quite a few correct. So it looks like they really tried to compensate. Okay? They really were trying to beat my hearing test. Again, if they were way down here, okay, or if they're on the lower end of this distribution, then they're going to be lying about their ability to hear. this individual really tried to beat that test, but they still were not able to kind of land within the realm of the deaf people. So here it looks like when 100 trials are computed, again mimicking deaf people, they pretty much stay between 40 and 60. And this individual was at 36. So let's answer the last questions here for this set of notes. What do you think about the subject's claim that he suffered from hearing loss? Okay, so if the subject indeed suffered from hearing loss, I would anticipate that their values would not really go below 40 here for the number of correct. Okay, so what do you think about the subject's claim of hearing loss? I don't believe this subject suffers from complete hearing loss. If they did have hearing loss, then their outcome should be similar to deaf people, to a deaf person. Deaf people are not likely to get less than 40 out of 100 trials correct. This individual only got 36 correct. All right, how about the last question? Your friend makes the following statement. This subject got too few correct in this hearing test, so this person suffers from hearing loss. Now that statement is incorrect because of the way that this test was done. So too few correct would actually indicate that they're lying because of the setup of this hearing test. Maybe if we do some other hearing test, a different type of hearing test, not getting any correct would indicate that they're deaf, but not the one proposed here. The one proposed here, a deaf person would actually get some of the answers correct. So this statement is incorrect because a deaf person has a 1 out of 2 chance of being correct. With 100 trials, a deaf person should get about 50 correct. So values near the middle are likely outcomes for a deaf person. All right, let's go ahead and submit our notes, and that'll do it for this video, which again was for Module 1 Part 2.